On note 6.1, we're going to be looking at relations and functions. A relation is a set of ordered pairs. So anytime you have more than one ordered pair, that's considered a relation. There are several ways of describing a relation. You can have a list of ordered pairs. Remember, X comes first and then Y. You can have a graph. So you're given some points on the graph and you can easily write those as ordered pairs. Mapping. The first bubble will represent X, and then the second bubble will represent your Y values. And then you can change those to ordered pairs as well. So it would be 0, -2, 0, 2, and then you could keep going. And then you can have a table. On the table, most of the time, it will label X and Y for you. So X is the first column, Y is the second column. And then the next part is you're given an equation, and then you're given some X values. We can take those X values and plug them in for X and find Y. When we do that, we can change those to ordered pairs. So X would be 0. If we plug it in, we get 4. So 0, 4 would be an ordered pair. So those are the different representations of a relation. The next part we're going to look at is domain and range. So domain of a relation is the set of input values, which are your x's, and then x will be your independent quantity. Range of a relation is the set of output values, which are your y values. Y is your dependent quantity, so your y value will always depend on your x. A way that you can remember is D comes before R, X comes before Y. So domain is X, range is Y. Okay, so we're going to find the domain and range of the relation above. So we're going to look at those ordered pairs at the very top. Anytime you're listing domain, we know those are your X, and you'll have a curly bracket. I'm going to go up to the top and look at my X values of my ordered pairs here. I like for you to put it in order from least to greatest. So smallest X value would be a 0. Oops. And then next would be a 3. Notice there's 2 3s, but we will only write it one time. And then a 4. And then close your brackets. Range is your Y. So on range, we're going to look at the Y values of our ordered pairs. Same thing, curly bracket and least to greatest. So that would be -2, -1, 0, and then 1 and 2. Okay, so anytime you're given a relation, list of ordered pairs, you can easily find your domain and range by listing out the X values for domain, the Y values for your range. Okay, on the next part, we're going to talk about a function. A function is a relation, which we just went over as a set of ordered pairs, in which each X value corresponds to exactly one Y value, which means no X coordinates are used more than once. Determine whether each of the following relations is a function. All right, so all of the X's have to be different. So when you're determining if it's a function, you're only looking at the X values. So notice there we have 2 different 0s and 2 different 3s. So therefore this would not be a function because the X values repeat. The next one, same thing, look at only the X values. Notice they're all different, which means it is a function. Okay, so on 4 we have mapping. So remember this is X and this is a Y. I can change those to ordered pairs if I wanted, or just look at the mapping. Notice we have ones that repeat, so therefore this is not a function. We have a table on example 5. We're only looking at the x values and all of them are different, which means it is a function. Okay, so we had a set of ordered pairs, we had mapping, and we had a table. We determined if it was a function by looking at just the x values. Now, whenever you have a graph and you're determining if it's a function, you're going to be using the vertical line test to determine that, or to determine if your x's repeat or not. So it says a relation is a function if no vertical line intersects its graph more than once. So if you look at example 6, if you draw any vertical lines here, we only want it to be intersecting at one point. So none of those will repeat there, which means this would be a function. If you look at 7, every single time I draw a vertical line, notice we're intersecting at 2 different places, but we can only intersect at one place if all of the x's are different. So this would not be a function. Notice on 8, if we draw a vertical line through those points, they repeat. So that's not a function. Okay, next part. We're going to find the indicated value of f of x. F of x is the same thing as y. So it says f of x equals 5x minus 1. So you can also write it as y equals 5x minus 1. It says we want to find f of 10. That means x is going to be 10. So we're going to replace every x with 10 here. So we're going to get 50 minus 1, which would equal 49. There's your answer. We could also write it as an ordered pair, 10, 49 if we wanted. X is 10, y is 49. We plugged it in and we found y. Example 10, we're doing the same thing, but this time x is negative 3, so we're going to plug in a negative 3 for x. Negative 3 squared is a positive 9, so we add 2 and we get 11. There's your answer. Again, we can write it as an ordered pair, negative 3, 11. All right, let's look at the page. Okay, so it says state the domain or range of the following relations and determine if the relation is a function. So on this one we have a graph. We're going to have to determine if it's a function or not after we find the domain and range. So x is your domain. So look at the x-axis. We're always looking to find the smallest x value and then the largest x value. But if you notice here, this value here, there's an arrow, which means it will keep going to the left. Notice here, it'll keep going to the right, which means there's not a starting and stopping point. So this would be all real numbers for your domain. The symbol for that is 2 vertical bars and then connect your R. If we look at the y-axis, notice it's the same thing. If we want to look at the smallest y value, it's going to keep going down. It's also going to continue to go up. So your range would also be all real numbers. If we use the vertical line test or pencil test, it's only intersecting at one point, so it would be a function, and this is actually a linear function because it's a straight line. Anytime you have a straight line linear function, it's all real numbers for domain and range, and then it will always be a function. Okay, let's look at 12. This one's different because this is a line segment. So domain is x. Look at your x-axis. The smallest x value on the x-axis is right here. So that's a negative 6. Largest x value is 6. Notice that we're including all of the points in between those also. So I'm going to put x in the middle. It's going to be an and statement. We're going from -6 to +6. If you always put the smaller one on the left side, then you'll have less than signs here. Now notice on our endpoints we have an open and closed point, so we need to talk about that. Open point means it doesn't include it, so not equal. The closed point means it does include it, so equal. If you look at -6, when x is -6, it's this point here. That means it doesn't include -6. But this one, +6, is closed, so it will include it. The range, look at the y-axis. The smallest y value being used is a 1. And then we're going all the way up to the top to 8. So it's including all of those values. So I'm going to have a y in the middle. It goes from 1 to 8. And it includes all the points in between. That's when we're having to set up an and statement. 1 is less than 8. Notice when y is 1, it's this point, which is closed. So it includes 1, but it doesn't include 8. If you use the vertical line test, it's only intersecting one point, so this would be function. Okay, next part, we have horizontal line segments. So domains x, if you look at the x-axis, smallest x value is -10. And it goes all the way to 6. Notice it's including everything in between those two numbers. So we're going to set up an and statement again. So x is in between -10 and 6. -10 is less than 6. When x is -10, it's closed, which means it's equal to, and then open on 6, which means it doesn't include 6. The range is going to be a little different on this one. Notice the smallest y value is -2, but it doesn't include in between numbers in between -2 and -1 and -1 and 0. It only includes -2, 0, 2, and 4. Those are the only 4 values that we are using on the y-axis. So you're just going to write -2, 0, 2, and 4. Because it doesn't include everything in between those two numbers because they're horizontal lines. Okay, determine if it's a function. If you draw a vertical line, it's going to cross through 2 points, but one of those points is closed, the other one's open, which means it doesn't include the open one. So this would be a function here because one of them's open, the other one's closed. If they were both closed, then it would not be a function because those x values would be the same. All right, let's look at the next part. Now we're going to graph and then determine if it's, or determine the domain and range and determine if it's a function or not. So notice on 14, y equals 3x minus 2. This is linear. Slope, I'm going to use slope and y-intercept to graph it. Slope is 3 over 1, y-intercept's -2. So I'm going to begin with b, which is the y-intercept. It's crossing at -2. And then we're going to use the slope, up 3, right 1 to find the other points. I could continue to plot more points if the graph was larger. So whenever I connect the points, I need to draw arrows at both ends because it's continuous. Remember, we just talked about a linear graph on the front. Domain and range of a linear graph is all real numbers because it's continuous both directions. It's also a function because we don't have any x values that repeat. All right, next part, we're just plotting the 5 points here. So go ahead and start plotting those. Okay, so we cannot keep plotting points because these are the only 5 points that we were given, and we can't connect the points. So in order to find the domain and the range, we're just going to list them out. So you can just look at either the ordered pairs or look at the graph. So the smallest x value would be -3, and then 3, 4, and 5. The range, which is your y values, smallest one is -2, and -1, 1, 2, and 4. Okay, we need to determine if it's a function. If you draw a vertical line, it will intersect here at 2 different places. You could also just look at the ordered pairs. Notice that -3 repeats, so this would not be a function. Okay, last one. We have vertical bars around x minus 1. That means absolute value. Anytime you graph absolute value, it should be a V. I'm just going to make a little table here so that way I can figure out some points that are on our graph. I'm going to just pick some x values. I'm going to pick -2. So I'm going to plug it in here. -2 minus 1 is going to be a -3. But absolute value is, remember, is the distance the number is from 0. So that's going to give me +3. If I plug in a -1 here, -1 minus 1 is a -2, but absolute value of that is 2. 0, we get -1, which absolute value is 1. 1, we get 0. 2, we get 1. 3, we get 2. So those are some points that we're going to plot, so that way we know what the graph looks like. -2, 3. -1, 2. 0, 1. 1, 0. 2, 1. 3, 2. And we could keep going. So when you connect them, draw arrows. So notice we do have a V. Domain, look at the x-axis. If we look here, we can't stop there because there's an arrow. We can't stop here because there's an arrow. So it's continuous. So domain would be all real numbers. Let's look at the y, the range. Notice that's not going to be all real numbers because we're going from 0 and then it's continuous. So our range would be y is greater than or equal to 0. Because remember, the absolute value of a number is the distance the number is from 0. So it's going to be always positive. If you use the vertical line test, you would determine that it is a function because none of the x values repeat. Alright, so here's notes 6-1 over relations, which is a set of ordered pairs, domain, which is the x values, and range, which is the y values.